Energy conservation principle, nothing else. Energy conservation. You know what is energy conservation, right? Energy conservation, we know or not? We cannot create energy, we cannot destroy the energy, total energy in the universe remains constant. That is what energy conservation principle now. Energy, but we can transfer one form of energy to another form of energy. Same concept here. When the some pipe is there, some fluid, some flow is taking place through a given pipe. So the total energy of the pipe or the total energy of the flow remains constant. That's nothing but Bernoulli principle. See, I'll tell you a very simple thing. Suppose one pipe is there like this. I'll purposely draw the pipe like that. So this side more area of cross section, less area of cross section. And here, this is the ground with respect to the ground. So here what happened means, see here, this is the having some height H1. And here it is having some more height H2. And this is say something like here, area of cross section A1 and fluid entering with velocity V1. And here area of cross section A2, fluid is exiting with velocity V2. Are you okay? Now, in this kind of situation, one pipe is there in this scenario, different area of cross section. Clearly, you can say here to here, this is more area and this is less area. So fluid is flowing from here to there. So area of cross section decreases means must be velocity will be increases. That can be true only in case of the horizontal pipe. Why? Because potential energy will be same. But here, because of the pipe fluid is that existed with in the gravitation also, there is a 3 types of energies will be existed for pipe flow means through a pipe some flow liquid is taking place. So it will be having 3 types of energies. What are the 3 types of energies means? First one is called, because of the velocity, it can have kinetic energy. And because of the position, less height, more height, whatever it is there, so it can have potential energy. And because of the pressure, means it is going with some pressure. So inside there is some pressure is there. So because of that, it can have third one is that called as pressure energy. These 3 energies are there. So Bernoulli principle is telling that for a regular laminar flow means is telling that ideal fluid or ideal flow. Ideal fluid means the fluid must be incompressible, non-viscous. Actually, we don't get ideal fluid, but Bernoulli principle exactly can be applicable only for the ideal fluid. So ideal fluid, for an ideal fluid, what is ideal fluid means? A fluid must be incompressible and non-viscous. And the flow must be a streamline flow, not a turbulent flow. So these 3 conditions are there. So such a flow, the total kinetic energy, potential energy, and pressure energy of the fluid at any given point remains constant. Statement clear? We'll see here. Bernoulli principle, Bernoulli theorem states that sum of the pressure energy, kinetic energy, and potential energy. These are the 3 possible energies for a given fluid. What are the energies? Due to the pressure energy, due to the velocity, kinetic energy, due to the position, means it is a horizontal or vertical or what kind of position is there. So that is what we can call potential energy at any point in a steady flow, ideal fluid, that's it. And calculated per unit mass over per unit volume is constant. This and all not required. The total energy for a steady ideal fluid is constant. See, another way is telling that Bernoulli theorem can also be stated as follows. In a streamline flow of fluid, the sum of gravitation head, pressure head, and velocity head at any point of the path of the flow is constant. Here, what is means of gravitation head, pressure head, velocity head is just nothing but potential energy per unit volume, unit mass. This is what we can call as, this is the pressure energy per unit volume, unit kinetic energy. I want to tell you these things. Why? If I say like this, you don't understand. Simple, ma. I'll tell you. See, fluid is there. What is the kinetic energy? Kinetic energy formula of mv square. Kinetic energy formula of mv square. So can I write in terms of, I can't measure the mass. Can I write mass in terms of density into volume? Density into volume into V square we can write. This is the kinetic energy. Kinetic energy formula for a fluid is going with velocity V and volume is there. So can I write like that? Then kinetic energy per unit volume. Kinetic energy per unit volume means volume make it unit. So then which is equals to what I can write means of rho V square. This is the thing you remember. Kinetic energy per unit volume, what you can write like a of rho V square. So here what is telling that statement? So pressure head, velocity head is there, that like that is the link. So pressure unit mass you can write of mv square, no? So per unit mass, unit weight, all these things. Here P by rho is called pressure head. So P by rho, this much per unit weight is telling that. We'll see that. This is what you can write, kinetic energy per unit volume. This can I write like this, kinetic energy per unit mass? Can I write like that? Kinetic energy per unit mass, can you tell? This is the half mv square. Mass will be unit quantity. So if I make it unit, kinetic energy, can I write like that, half v square? Half v square, what you can write? Kinetic energy per unit mass. This is what kinetic energy per unit volume. Is it any confusion, students? Kinetic energy per unit volume, I can write it as of volume will be there of rho v square. Same kinetic energy per unit mass. Unit mass means mass make it one unit. Can I write of v square? Of v square is the kinetic energy formula. Can I write like that, kinetic energy per unit weight? Unit weight means I want to multiply it with weight. Unit weight means what I can write means of mv square is there. Now multiplied with g, divided with g, small g, weight. Means m into g we can call it as a unit weight. That is what we can write, of mg v square divided by g we can write. This is the weight formula. Mg is nothing but weight. So what I can write means for unit weight, what I can write means of 2g v square can I write. Mg will be unit weight, v square by 2g. What it is there? Unit weight formula. This is a v square by 2g. This is also called as, this is the pressure at the velocity head. This is called as velocity head. This is called velocity head. Same like here, two things are there, like a potential energy also we can able to write here. Related to potential energy, pressure energy also we can write. So here potential energy formula is what? Potential energy is equals to mgh. Potential energy formula. So this is general formula. Can I write potential energy per unit volume? I want to write. Unit volume means potential energy per unit volume. What I can write? Mass is there. Mass is equals to density into volume. Density into volume into g into h we can write. So can I make it volume constant? Unit volume, no. So potential energy per unit volume is equals to, can I write like this, rho g h. Volume become 1. You remove the volume. So volume 1 unit means here volume will be 1 unit. Unit volume rho g h. This is the formula. Suppose already we discussed like here, unit mass can you write? So what is this? Potential energy per unit mass. Can you say mass make it unit? That is equals to g into h. Potential energy per unit mass, gh. Same thing like a potential energy per unit weight. Can you say the formula? Weight means what? Mg called weight 1, that is equals to only h. Here mg will be equals to 1. And unit mass, here m is equals to 1. Here volume is equals to. Are you clear this? Terminology, all your potential energy formula, just mgh only, but we are using different scenario. And in Bernoulli principle, we use this only, potential energy per unit volume, that is equals to rho gh. Rho gh represents potential energy. And here, kinetic energy per unit volume, this is only we are using, that is half rho v square. And same thing, like one more thing is there, that is called pressure energy. So here, pressure energy. Pressure energy is equals to the product of pressure and volume. That is called pressure energy. Pressure energy equals to the product of pressure and volume. Same, you can write like that formula. Whatever formula we can write means pressure energy per unit volume is equals to, volume will be unit P, bracket, volume will be 1, unit volume. Suppose pressure energy per, so what is there? Unit mass over, can I write unit mass, unit weight? So here unit mass means volume, write down. Mass, like a density is equals to mass by volume. Volume is equals to mass by density. So unit mass, volume can be write like that. So that is nothing but P by rho. Mass make it unit. Volume you can write mass by density. So mass become 1. So this is also you can write like this. Pressure into mass by density, volume I can write. Mass become 1, P by rho. So that is pressure energy per unit mass. Same like here, pressure energy per unit weight. Can you say, students, I want unit weight. Weight means multiply with G, divide with G, mg. So that these two will become 1. That means that is P by rho G. Here mg become as unit weight. And here per unit mass, here m is equals to 1. Now here this is called pressure head. This is called as pressure head. And here this is called mass, weight, no, potential energy. This is what we are called as velocity head, pressure head. So this is what another name. Rho by P by rho is called pressure head. V square by is called as, it did not give, called as gravitational head. V square by 2G called as gravitational head, pressure head. This is called V square by 2G, where it is. Potential energy, velocity head, gravitation head. Okay, that kind of things. So just you carefully remember these formulas. Very important we are using. So kinetic energy per unit volume of rho V square. And here potential energy per unit volume rho GH. And here pressure energy per unit volume P. Pressure energy per unit volume will be P. Sum of these three energies, Bernoulli principle. So what is this? Pressure energy per unit volume, kinetic energy per unit volume, and potential energy per unit volume. Sum of all these energies, pressure energy, kinetic energy, potential energy, sum of all these volumes, sum of all the energies remains constant per unit volume. This is called Bernoulli principle. Yes or no? So here per unit mass is writing, divide with the mass. Per unit weight is writing, and per whatever it is there. So you just want to write P square by G is called pressure head, velocity head, or different names. So what is a Bernoulli principle means? This one. Are you clear? Statement. So for two different things you want to write. So two different things means one pipe is there, like here different velocities, different area of cross sections. So usually we used to write like this. So that means what means here height is h1 and here the height will be H2 means I want to show some kind of potential difference. I want to show some variation of kinetic energy because here area 1 liquid is entering with velocity V1 and here area 2 liquid is exiting with velocity V2. Okay. So now here what is this kinetic energy means? Here say that pressure P1 means here going with the pressure P1. Here it is coming out with the pressure P2. Right. So can I apply Bernoulli principle for that? Means what I can write means P1 plus half rho V square. Rho means density, same liquid is flowing. Density here, density will be same. So I can write half rho V1 square. This is what pressure energy, this is what kinetic energy plus rho G H1 must be equals to constant, no? Other side you write down, that is equals to P2 plus half rho V2 square plus rho G H2. This is your Bernoulli principle. Equal is important. If horizontal level heights are equal means you can cancel the potential energy. Potential energy is not mandatory. If the height variation is there, suppose one pipe is there, that is what is writing. Well, this is the diagram. I draw reverse. I draw like this. Is drawing like this. Anyway, the equation of Bernoulli principle is this one. P1 plus half rho V1 square plus rho G H1 should be equals to P2 plus rho V2 square plus rho VG2. Suppose the pipe is horizontal, H1, H2 equal, this term will be cancelled. Suppose, let me take like that also. Suppose I'll take this pipe horizontally. But the variation of cross section area is different. Means here more cross section, here less cross section is there. Okay. But horizontal pipe is very horizontal. So in this case, means this is a height H. Here also same approximately, there is no change, height H. So now here area of cross section A1, velocity entering is V1. Area of cross section A2, velocity is here area of cross section A2 velocity coming out V2. So can you write now Bernoulli principle? This is a horizontal pipe. Horizontal pipe means here potential energy is equal, is a constant. Okay. So that time can you write here? Here pressure will be different. Here pressure P1, here pressure P2. So now can you say like that? What I can write pressure P1 plus half density will be same only, half rho V1 square plus rho GH plus is equals to P2 plus half rho half rho V2 square, half rho V2 square plus rho GH. Because height here height is same, so the potential energy will be equal. So in that case, you can cancel this term. If the height variation is there, then only you can consider, otherwise not required. So then your formula will be, what is your formula? So P1 plus half rho V1 square must be equals to P2 plus half rho V2 square will come. Am I clear this? This is your simplified form of Bernoulli principle. Only this is valid in case of horizontal pipe. And from this, what I can able to write means for horizontal pipe, this P1 minus P2, suppose somewhere high pressure, somewhere low pressure is there. Pressure difference is nothing but velocity difference. So can I write like that? P1 minus P2 means P1 if I bring this side. So then you can able to take it out other side. So I can write it as half rho V2 square minus V1 square. Will you okay? As here pressure, one thing you remember students, the total energy remains constant. Energy constant means, some example I want to tell you. Applications tomorrow I will discuss now. I will tell you that time. So just remember up to here. We'll continue the class. Okay. That is a pressure difference. There nothing but velocity difference. Up to here you read concept related. Anything else I'll continue tomorrow. I have other class. Okay. with lot of examples, applications are there related to Bernoulli principle, we will discuss.